In this video, we're going to do a quick review of writing chemical equations. So chemical reactions can be represented by what's called a chemical equation, which is a nice simplified way to explain what's going on in a reaction. There's different types of chemical equations you can have. You can have what's called a word equation. A word equation is where you write out the reactants and the products using words only. So typically when you have an equation, you have reactants on the left side. Those are the things that are you're starting off with. They're the things that are mixing together and they're about to react. They're your ingredients, in other words. And you write each reactant out and you separate them by a plus. So almost if you're writing a recipe. So eggs plus sugar plus milk plus flour. And then to show what they make, you put an arrow. You don't put equals. You show what they produced because they're not equal to it. They make something new. They'll make something in the end. Whatever they made in the end, that's called your product. And that's on the right side. So your reactants are on the left side. Your product is on the right side. And they're all separated by arrows. Now, we can represent this in word format, word equation. For example, I might have sodium reacting with chlorine. So I'll put plus chlorine. And they're going to produce, so I'll put an arrow to say produce, sodium chloride. And you simply put the words, you don't put states or anything like that. You don't put sodium metal or chlorine gas or anything like that. You just put the words of what the chemicals are. That's it. Now, the thing is, not everyone speaks English. Not everyone would understand this. Not everyone, some people might write this in French instead. Sodium plus chlorure gives produit chloride de sodium. And you wouldn't understand that either. If you speak other languages, you might have others. You might have other words there. And not everyone understands that. So something everyone understands would be the what's called a skeleton equation, where you, instead of writing words, you put a formula for what you're trying to write, or a symbol. And that symbol can come from the periodic table and from our writing of formulas that we learned. It doesn't matter whether you know that chlor is chlorine or chlorure de sodium is sodium chloride. If you have a formula or the symbols, everyone understands what you're trying to say. So I'm going to write the same thing that I did above, but just translate it into what's called a skeleton equation using symbols and formulas. So sodium is Na. Chlorine, you might remember this, it's one of your Hofbrinkel elements, is Cl2. Put an arrow, sodium chloride. That's just the formula for sodium chloride, NaCl. Generally, in skeleton equations, you can put states in there. For example, I might say it's solid sodium. This I might say it's in the gas form. And this I might say is solid sodium chloride. So I can actually put states in this case. The last type of equation is called a balanced equation. And a balanced equation is very similar, except that it actually follows what's called the law of conservation of mass. It basically ensures that both sides of your equation have the same number of atoms. So let me just quickly show you this example here. So in our previous example, we wrote this out. But what you would notice is that here you have two chlorines and here you only have one. So you're missing a chlorine. You shouldn't be. If you had two chlorines on the left side, you should have two chlorines on the right side. So to balance the equation, we play with the coefficients. The coefficients are the numbers that you can put in the front. So I can put a 2 over here, and that will mean I have two sodiums and two chlorines now. And I can put a 2 here. So now I have two sodiums here, two chlorines here, two chlorines here. And that's a balanced equation. So the word equation summarizes the reaction using the words. However, remember that not everyone speaks the same language. So this is not universal and not everyone gets this. To prevent us from making mistakes like that and so that we can all understand, we can use the skeleton equation. And the skeleton equation, instead of using the words, we'll use symbols and formulas as you see here. Everything is written in the same sort of position and spot. We have our plus and arrow still. It's just that we have our symbols and formulas instead. And we can also put states of matter like solid, gas, liquid, or if it's dissolved, aqueous. Balanced is very similar to skeleton, except we're being more specific with the exact number of each thing reacting. So 2 reacting with 1 to make 2 of these. And we make sure it follows what's called the law of conservation of mass, which basically means that if you have 2 chlorines on one side, you better have 2 chlorines on the other side. You have to account for it because you're never destroying the atoms, you're just connecting them in different ways. And so those are the 3 different types of chemical equations that you can use to represent chemical reactions and to summarize them in nice, easy ways to understand.